Hi, Math 120 students. This is Dr. G. I'm going to be making videos from time to time this summer. I'm going to be posting them in Alex, in the lessons, or with the topics that they go with, and I'll be posting them on Canvas. And I'm going to do this not with every single topic, but with the topics that I know most students in Math 120 will have trouble with, or topics that I think need an alternate explanation. So in Alex, you'll see one explanation, sometimes two explanations for a concept, and you'll see often a video that goes with the textbook that might be a third explanation, or it might be the same as the one given in Alex. And then sometimes you'll see my explanation. So this is just an alternative explanation sometimes for topics that just might need more than one explanation. So the one I'm doing right now is on absolute value. And this is because it's a very difficult topic for most Math 120 students. And it's something you're going to see all summer long. The problems are going to get more complicated, and there's problems involving equations, involving inequalities, and involving graphs. And so there's not just one procedure. When I was a student, I thought, I can't remember the procedure. I don't know what to do with an absolute value. There's a procedure I forgot. And there isn't. There isn't one procedure to remember. There's a concept that will help you deal with absolute value. But one procedure, no, it will fail you. It'll work for some problems and not work for other problems. So what I want you to do is get the conceptual understanding down early on so that you won't be stumped by absolute values when they come up in harder and harder problems. So the idea that I want you to grasp and to remember is that the absolute value of a real number is simply the distance that that number lives away from zero on the number line. It's just the distance that number is away from zero. So here's a number line. And remember, the number line, you can go two directions. There's positive direction on the right, negative direction on the left, and it goes on forever. There's infinitely many numbers on the number line, infinitely many numbers in between each of the numbers that I've written here. So like between 2 and 3, there's a lot of numbers between 2 and 3. I just can't mark them all off. Okay, so let's start with a simple example. Let's start with the absolute value of A equals 3. So what does A have to be if it satisfies this equation? Well, remember that just means that the number A, the thing inside, is exactly 3 units away from the number 0. That's all it means. The absolute value of A is the distance away from 0. So this number A is a distance of 3 away from 0. So let's find it. I start at 0, mark off 0, and then I start walking 3 units away. I'll go to the right, 1, 2, 3, and I land at positive 3. No surprise. So that just means the number A has to be 3. But what if I walked in the other direction? You have to remember there's always 2 directions. You're starting at 0, and you could go to the right or to the left. So now let's go to the left. I go 1, 2, 3. I land at negative 3. That's also a number that lives 3 units away from 0. And there's no other direction to go. I've got 2 possible directions, so there's 2 possible answers. So that means A is positive 3 or A is negative 3. So let's put this concept in a box. So what does it mean when you say absolute value of A equals B? It means A has to be B or A has to be negative B. Okay? So B is a positive number because, well, why is that? Why do we say absolute value has to be positive? It's because it's distance. always remember distance is always positive. We never say, he lives -5 miles from me. We just say, he lives 5 miles from me, and then we have to say which direction, right? The distance is always positive. The direction comes later. So when we say absolute value of A equals some number B, well, that number B better be positive. And then the number A, the thing inside the absolute value, well, that could be B or it could be -B. All right, so this is what we're going to use from now on. So let's look at some examples. So the first example is kind of one of the first problems that you'll see in ALEKS. We're solving an equation. We're solving for the variable v in this equation. And the equation says -8 times absolute value of v plus 2 equals -72. So it says if we get more than one solution, separate them with commas. If there's no solution, click on no solution. So for this one, we look at it and we want to use this concept that I've just put in this box up here. And it says that absolute value of A equals B means, and I don't have an absolute value of something equaling a positive real number. I have -8 times an absolute value of something equaling a negative number. So I want to make it look like absolute value of A equals B. So that means I want to isolate the absolute value. And in this equation, to isolate the absolute value, I have to get rid of that -8. Since it's multiplication, that means I'm going to divide. So I'm going to write down the equation here. And then I'm going to divide both sides by -8, so I can get rid of the -8. On the left, I'm just left with the absolute value of v plus 2. On the right, I get +9. Great. I have an absolute value of a real number is equal to a positive real number. That's exactly what we need. So now to use that concept that's up in the box, what does this mean? That means if we want to take away that absolute value, the thing inside, we don't have an A, we have a v plus 2, but that's okay. The thing inside, we have two possibilities. Either the thing inside is 9, or the thing inside is the opposite of 9. And now we can solve these two equations separately. So the one on the left, to get rid of that 2, I subtract 2 from both sides, and I get v is equal to 7. The other equation, I subtract 2 from both sides, and I get v is equal to -11. So I have two possibilities. And when I put them in ALEKS, I'm going to separate them with a comma. So remember that we had to first isolate the absolute value, and then we had to use that concept that I put in the box. The absolute value of a real number A is equal to a positive real number B just means that A is equal to B or A is equal to the opposite or the negative of B. All right, let's look at another example. Let's get a slightly different problem. So this one we're solving for W. It says 5 times the absolute value of 3W is equal to -75. So once again, in order to use that concept, I have to first isolate the absolute value. So in this case, I need to divide both sides by 5. Once I do that, I get the absolute value of 3W is equal to -25. And I hope you're saying, whoa, how can that be? I thought she just told me that absolute value was a distance, and distance is always positive. And you're right, that's what I did tell you. On the left, we have something that is positive. On the right, we have something that is not positive. So what does that tell us? That we have no solution. There's no way we can find a real number that will satisfy that equation. So just remember, absolute value is distance, and distance is always positive. All right, let's look at a different concept using absolute value. What if you have two real numbers that have the same absolute value? the absolute value of A is equal to the absolute value of B. Well, what does that mean? If you remember that absolute value is just distance away from 0, this equation just means that the number A and the number B are the same distance, are exactly the same distance from 0. Okay? So what does that mean? How could two numbers be the same distance from 0? Well, let's look at the number line again. So here's my number line. I'm just going to show you an example of two numbers that are the same distance from 0. So take the number positive 3. What's another number that has that same distance away from 0? So positive 3 is a distance of 3 away from 0. Well, we know that negative 3 is also a distance of 3 away from 0. So 3 and negative 3 are the same distance from 0. 3 and 3 are the same distance from 0 because they're the same number. Okay, so the absolute value of 3 is equal to the absolute value of negative 3. Also, we could say the absolute value of 3 is equal to the absolute value of 3. Well, duh. Or I could have said the absolute value of negative 3 is the same as the absolute value of negative 3. Okay. So basically what we're saying is they're either the same number or they're opposites of each other. That's all it means. So that's what I'm going to write here. The absolute value of A equals the absolute value of B just means that A and B are the same, A equals B, or A equals negative B. They're opposites of each other. Okay, so when you see two numbers have the same absolute value, there's only two possibilities. Either they're the same number or they're opposites of each other. So let's use that concept on this problem. So we have an equation that has two absolute values. The absolute value of negative 1 minus 3y is equal to the absolute value of y plus 5. So we're going to use this concept in the box on the left. It says that we've got two possibilities. If we want to take away the absolute value symbols, we've got to write down two equations. The thing inside of each of the absolute values have to be the same number or they have to be opposites of each other. So the thing inside on the left is negative 1 minus 3y, that's our A. And the thing inside on the right is y plus 5, that will be our B. So there's two possibilities. Either A is equal to B, which means negative 1 minus 3y is equal to y plus 5, or A is equal to the opposite of B. So negative 1 minus 3y is equal to the opposite of y plus 5. And notice I put parentheses around y plus 5 because y plus 5 is our B. And so I'm taking the opposite of B, which means the opposite of y, the entire expression, y plus 5. So I had to put parentheses there. All right, so let's solve these separately. The one on the left, I've got y's on both sides. So let's get all the y's on the same side by adding 3y to both sides. You might solve it differently, doing things in a different order. That's okay. So when I do that, I get negative 1 is equal to 4y plus 5. Now I'm still trying to get the y by itself, so let's subtract 5 from both sides. When I do that, I get negative 6 equals 4y. Now I want to get rid of the 4, so let's divide by 4. So y will be equal to negative 6 fourths, and always simplify your fractions. So y is negative 3 over 2. Okay, let's go to the other equation. So I've got that minus sign outside of the parentheses. So first thing I have to do is distribute the minus sign before I start combining like terms. So I've got negative 1 minus 3y equals negative y minus 5. So now let's do the same thing. Let's add 3y to both sides. I've got negative 1 equals 2y minus 5. Let's add 5 to both sides. So now I've got 4 equals 2y. If I divide both sides by 2, I get 4 over 2 is y. Simplify that fraction. I've got y equals 2. So now I'm done. I've got two answers, negative 3/2 and 2.